Okay. Um, I'm not reading it off.
No worries.
Okay, 1 and 2. That's true. Okay. Oh, shoot! Alright, in a pie chart, why are the slices, sectors, different sizes?
Is that the second one?
Yeah, well, that's like the biggest answer, so it has to be right. Just kidding. How are bar charts and Pareto charts related?
The last one,
Were you already working on this?
maybe.
Okay, real quick. So tell me what the difference would be, though, between a bar and a Pareto.
The only difference is that the Pareto counts. Is it down?
Yeah, it's in descending order on the Pareto chart.
Yeah.
That's all
And
it
the
is.
bar charts
It's
count
the same
up.
information. It's just organized differently.
You passed the test. Okay. We conclude that p hat is normally distributed if np is greater than or equal to 10, and n, parentheses 1 minus p, is greater than 10. Is p the true proportion of the sample proportion?
It's the true proportion.
Yep, that's what I put.
That's what the hat's for. Shows it's true, like Abe Lincoln. Okay, what is the n? Isn't that always the sample size?
Yep.
Yes.
All right, if p equals a quarter, what is the smallest n that satisfies the requirement?
Come on, Burke, you didn't calculate this already?
No, I stopped at 6.
Um,
I'm calculating it though.
40.
Okay, so it's 1/4 times the equation 1 minus 1/4 again, divided by the sample and then the whole square root.
Yes.
Just making sure my equation's all right.
40?
96. Sorry, what'd you get?
40?
That's what I got, but I don't know if I did it right.
Like, if you do the second one for the n times 1 minus p, like it's like 13.3, I believe.
Yeah.
But the other one would require at least 40, which would fulfill both of them.
Right.
Wait, so how'd you do that?
Algebra. So I plugged in p for where it's up on those equations,
Right.
and then I just had 10 on the other side, and I just solved for n.
Oh, duh.
Um, 10, yeah. We did this one,
I can do that stuff.
and this wouldn't require any decimal places, right? Because it's
No, it shouldn't.
Just one number.
sample size.
Okay, so now we switch up stuff. Now 8 and 9, suppose n is 24 and p is 0.4.
So it'd be 0.4.
So the mean is p hat equals p. So would that be 0.4?
Yep, it'd be 0.4.
Okay.
The standard deviation is that little square root equation.
So the square root of 0.01.
What?
Unless I did it wrong.
Hold on, I gotta calculate it. Give me 1 second. So 1 minus p 4 times 0.4. You said the square root of 0.01?
Yes.
You get 0.1 then, right?
That's what I got.
Yep.
Are these things supposed to be the decimal places?
It didn't say. And there aren't any? Oh, wait, we can save for later. Hang on, I'll see. Group meeting. Meet with your group, blah, 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 do the same thing.
I don't think so, because the very next question says 2 decimal places, and the one after that says 3 decimal places,
Yeah.
3 decimal, 3 decimal.
There's nothing in the instructions either, so we should be fine.
Cool.
All right, p hat is 0.030 or 0.30. Righto. Okay. For 11, I got 0.0458. Or 4.
You use the probability applet, don't you?
Yeah.
Oh, for the z-score?
Yeah, because you calculate the z-score with the value minus the mean over the standard deviation.
Right. Do you have your probability app open?
I don't. Not yet. I can get it real quick, though.
Is that lesson 5?
Yeah. It was in the exam file too, so.
Oh, yeah. Nice. Normal distributions. Pulling up this graph. There it is. All right. So plug it into the area. 0.0458. Okay, so which ones do we shade then? So we want more, so would we just do the right side?
That's what I did.
Yeah, just the right side.
So you got 0.023.
Yep.
Hold on. Low. This is P.
P is the 0.30. Or what are you talking about?
How did you go about solving that? Maybe I just completely blanked, but
So 10, you already know what to do. For 11, did you already get that?
well, what is 10?
Well, 10's 0.30 because p hat equals p.
The mean of p hat equals p.
Oh, what? I thought it just equaled that.
I didn't mind. I'm just trying to figure out why. This is the part that I was struggling with most on the assignment. Was this p hat?
Struggle is real. Okay, so her batting average is her mean is 0.300. And then X. So isn't it 0.3 over 100?
I mean, it would make sense. P hat equals x over n.
Right.
But is that her batting average over 100?
See, I thought, like here it says the sample proportion p hat is normally distributed in is large. The true population mean of the random variable p hat is mean of p hat equals p. Is that what you're asking?
Where was that at?
Right at 3.2.2. Mean and standard deviation.
Yeah, so I was just like thinking of like, because it's wanting to know what the p hat is, not what the mean of the p hat is.
I thought that's what it said. Wait, so what did we do for 8 then?
Number 8 asks what the mean of p hat is, which is p.
Oh, okay.
But
And
this
then
one
this.
wants to know what p is. P hat.
Oh, okay. Shoot. Okay, look at the green box right under where you were looking, and then just click on Show Solution and see if that helps.
I think you might be right with that average over the sample size. Because if you look at like 3.3.1 worked example, it says if a coin is tossed n equals 25 times and heads is observed 17 times, the sample proportion of heads is p hat equals x over n.
Okay, so it's just the 0.3 over 100.
That's the only thing I can think of to calculate p hat. It's the average. So it's what she's sitting at for
0.003. But it says rounded 2 decimal places, which would just be 0.00. Or is p hat 35 divided by 100?
That might be it.
I think it is.
You're a genius.
Rats. Okay, now this equation's starting to make more sense to me.
Yeah, now there's everything to plug in. That's what I was getting confused about because we didn't. Okay, that was good. Nice call there. Because we want 30. Okay, that makes sense.
Yeah, well, it's the sample over whatever we're doing.
So 0.3.
Okay, so 0.35 times. Divided by 100. Okay, did you get 0.046?
6. I got 0.046.
Gosh dang it. Miss something? Well, you have your actual calculator, so
Yeah.
mine just might be shorthanding it.
0.3 times 1 minus 0.3
Once.
is 0.21 divided by 100 is 0.0021. Square root of that is 0.0458, which would be 0.046.
Okay, because when I did it, mine was 0.2275 divided by 100 gave me 0.00228.
And you just used the 0.3, right? Not the 0.35?
That's what I did wrong. Alright, cool. 4.6. And we plug that number in.
Minus 0.3. And that's the answer. You get 1.091.
Did you plug it in the area?
It just wants to know the z-score.
Sorry, my thing's going like really dumb right now. Just so. Okay, I got 1.685. Is that what you said?
Yeah, 1.091.
I got 1.0912, so.
What did I plug in wrong? What side did you guys shade?
The right side.
That's it?
Yeah, because it wants to know if she gets at least that.
And what'd you plug in for the area?
The area that it's going to give us is our probability, which should be 0.138 when you round to 3 decimal places. What you got, bro?
Yeah.
Okay.
Right, 14. If the true proportion of people who supported a political candidate is P equals 0.52 and N equals 2,000 people are surveyed, we want to determine the probability that the results of the survey will suggest the candidate is losing the election or getting less than 50% of the votes. What is the standard deviation of P hat?
Okay.
Five two. Oh, no, it's 5.52. 2,000.
Oh, okay. Did you get it? 0.011.
Yeah.
Yep.
Dude, I wish I had a really nice calculator now so I could just plug this whole thing in. And then our P hat. So for this one, what would our initial P hat be?
0.5.
Is that just because of getting less than 50%, right?
Yeah, that's what we would plug in.
Okay. So 0.5 minus 0.52. And then plug up the equation of standard deviation. Oh wait, we don't want to do that. Okay, so I got negative 1.818.
I got negative 1.790.
It's probably because I used just the 3 decimal places. One,
It can be.
not plugging it in all the way.
See what Brick gets.
Give me just a second.
Brooke.
I got negative 1.790.
Okay. It's probably because you guys did the whole equation.
I just plugged it in my calculator.
Mine's like a 10-digit one, like really garbage. Okay. And then what probability do you compute using the normal probability applet, since we're getting less than 50 votes? Why the freak do they use Z? Big Z, little z? I'm going to go with A. Oh shoot, computer's gonna die soon. It's too far away.
What's the difference between the big Z and the little z?
That's what I was just looking up. Alright. One computes a z-score scholar for comparing. That didn't tell me anything. The internet is no help. Okay. Okay, this is kind of what it says from someone. It says, I believe the big Z is simply to normalize in order to obtain a standard normal distribution. Once you normalize, you'll have an n minus 1 to 0 and be able to use probabilities based on standard normal distribution. And then for the small z, I think it's the formula for the test statistic. So basically they are used for 2 different purposes. One, to obtain a normalized variable in order to be able to use the standard normal distribution, and the other is used for hypothesis testing.
So the small z is our z-score?
I'm going to assume that's what it is.
That makes sense. I don't understand the big Z, though. Because we've got something similar to that in, like, the 3.3.2 example of political elections. And it's talking about, it says, to address this question, we first note that the survey will suggest that the candidate will win if more than 50% of the people surveyed favor the candidate. So we need to find the probability of big P, parentheses, P hat is greater than 0.5.
So that'll be little.
So is Z our p hat then?
That's what it sounds like.
And so we want to have the second one, right? Because we're looking for less than.
So you want little z to be greater.
Yeah. Because in the book it's got it flipped around, but they're looking at the chance that they're going to win. So if you think about it, it would be flipped.
Which part is that in?
3.3.2 example political elections. It's got the donkey and the elephant.
Okay, yeah, I see it now.
So if that Z is our P hat, then
I think the little z is always going to be the z-score,
yeah.
no matter what. Like, because before the z was that, and they don't change it in statistics. Like, oh, now it's something different. So we're going to go with B on that one?
I think so.
Okay.
Sounds good to me.
I mean, I can see it being that, so. Okay, what is the probability the survey results will show the candidate is losing even though the true P is 0.25? Or 0.52. Jeez Louise.
So we would just go back to the applet, plug in the Z-score, then shade to the left of that negative Z-score, right?
Correct. Now I gotta pull up the applet again. Would it just be the negative of our original z-score?
Say that again?
Wouldn't it be the same number, but or not positive? Hang on, I don't know.
Well, we had a negative Z-score.
Yeah.
So I think it's just, that's our Z-score for that probability. And we would just shade to the left of it to find the probability of getting less than that and still winning. I think. Get 0.037.
0.037.
Yep.
I hope these things are right. This section's confusing.
I think it is for the most part. I'm going to guess if we don't get them all right, we're going to miss 2. I don't know which 2.
Can you give me the probability of that?
Yeah. Let me finish doing my pie chart real quick.
Okay. I would actually like to see it in a bar graph, if that's at all possible.
Oh, shoot.
I don't like pie, it just makes me hungry.
Right?
Can I
Especially
read through these real quick?
Yep.
All right.
Okay. I'll do it today. It says 1 and 2, true and true. 3 is B. 4 is C. 5 is true proportion. 6 is the sample size. 7 is 40. 8 is 0.4. 9 is 0.1. 10 is 0.35. 11 is 0.046. 12 is 1.091. 13 is 0.138. 14 is 0.011. 15 is negative 1.790. 16 is B. And 17 is 0.037. Hey, we did it. Yeah.
Oh, apparently my dyslexia kicked in and I got 12 wrong. Whoops.
Uh-oh.
Oh well. Wait, did you guys get 12 wrong? Or did I just put it in wrong?
No,
I got
12 is right.
Whoopsies. Oh well.
Not too shabby. Alright, so I'll go through and I'll finish that stuff for our project, and I'll get that to you guys probably tomorrow sometime.